Hi everyone. In this video, we are going to talk about how to form a quadratic equation when the roots have been given or roots have been provided in the question, right? So let's first take an example and see how we solve a quadratic equation by factoring. In a previous video, I have already described how to solve a quadratic equation by factoring, and here we are going to take a quick example to see how that works out. So suppose our quadratic equation is like this. Suppose we have an equation like x squared minus 3x plus 2. Suppose this is our quadratic equation, x squared minus 3x plus 2 equals 0. That's our quadratic equation. Now if we have to factor it, on the left hand side we can do some factorization. So we can say x squared minus this negative 3x become, we can write it as negative 2x, and then one more negative x plus 2 is equal to 0. From here we can say, if we take x as a common factor between the first two terms, then we can say x minus 2. Then if we take negative 1, if we take negative 1 as a common factor, negative 1 as a common factor from the second two terms, then we can say here we will have a positive x and a negative 2. From here we can say, okay, what is our common factor? That is x minus 2. That's a common factor, and then we are now left with x and the negative 1. So positive x and the negative 1. That's what we are left with, right? So it will be x minus 1. So this is equal to 0. Now from here we say that, okay, so x minus 2 is equal to 0 or x minus 1 is equal to 0. So from here we say, okay, the two possible values of x are positive 2 or positive 1. So the most interesting thing that I wanted to show you here is that this is the form of a quadratic equation where we can clearly see the two factors of the quadratic expression. So on the left hand side we always have a quadratic function or quadratic expression, and when you factorize them, if you focus on the left hand side, you see that the expression has been written in terms of a product of two factors, and each of the factors are linear factors. Why? Because the power of x is 1. So these two linear factors multiplied together makes the two roots. And if you again look at it, you see that the two roots are positive 2 and positive 1, right? Positive 2 and positive 1. So as you can see that if x has a value of 2, then x minus 2 becomes a factor. Similarly, when x has a value of 1, x minus 1 becomes a factor. So simply by looking at the factor, we can also make a good guess. Now suppose let's look at the factor. So if the factor is x minus 2, that means one of the roots is 2. And also if in the other factor, if x minus 1 is the other factor, there again we can clearly see that 1 must be the other root. So simply by looking at the factors, we can make a good guess that, okay, so definitely 2 is one of the roots and 1 is the other root of this quadratic equation, right? So from here, can we write it like this? Can we say that, okay, if in this case, let's assume that 2 is equal to alpha and 1 is equal to beta. So if we assume like that, then can we write this quadratic equation? I'm going to write this one, right? Can we write it like this? Can we say, okay, so then we can say x minus alpha times x minus beta is equal to 0. And that's exactly the form that we wanted to discuss here, that when alpha and beta have been provided in the question, if in a mathematical question you have been given the value of alpha and beta, we can easily form the quadratic equation, and the quadratic equation is going to be exactly like that. Now we can of course remove the parenthesis and we can simplify it a little bit. So let's try to simplify this form. But up to this form, as soon as you know the value of alpha and beta, you can create the quadratic equation that's going to look like this. But if you want to remove the parenthesis, then it's going to be like this. So let's now try to multiply. So x multiplied by x minus beta. So let's say now we are going to use the distributive law of multiplication. So x multiplied by x minus beta, then negative alpha multiplied by x minus beta, right? That's equal to 0. From here again let's remove the parenthesis, so it will be x squared minus beta x, then minus alpha x plus alpha beta. See that? That's equal to 0. So from here we can say, okay, x squared, then can we take negative x common here? So if we say, okay, if we have negative x as a common factor between negative alpha and negative beta, here you see we get alpha plus beta. If you think about it, negative x multiplied by positive alpha gives us the negative alpha x. Again, negative x multiplied by positive beta gives us the negative beta x. So we took care of the two middle terms here, and now we are left with the fourth term, which is alpha times beta, that is equal to 0. So from here we can say that, okay, this equation now looks like x squared minus alpha plus beta times x plus alpha times beta, that is equal to 0. So this is our final quadratic equation. Now let me highlight this. Now in this form you can see that the equation now looks like x squared minus, if I replace alpha plus beta as uppercase S to indicate that this is the sum of the roots, so we can say, okay, x squared minus sum of the roots times x, plus if I replace alpha times beta with an uppercase P, which indicates the product of the roots, then this is equal to 0. So this is another interesting form of a quadratic equation. So suppose if you have not been given the roots separately, however they have given you the sum of the roots. Suppose they have said, hey, sum of the roots is 5 and product of the roots is 4, right? In that case, what will be the quadratic equation? Well, we can simply replace S by the sum of the roots and replace P by the product of the roots, then we can easily form the quadratic equation. So whether they provide you the roots individually, meaning separately, or they provide you the sum of the roots and product of the roots, in any case you should be able to form the quadratic equation based on the provided information. I hope it all made sense. Thank you for watching. See you in the next video.